going to talk on the modern Appsec versus generative applications. Here I'm going to take like the Appsec that existed before, like say 2020, like where the GenAI apps started coming, or like we started building code with GenAI, and going to compare how does those fare, and do we need to change something. That's the talk going to be. So before we go into the content of the talk, I just want to like give some insights on how did I come to this talk, like why am I talking about this. So this was like end of 2022 when the ChatGPT came with like the inference, how it was getting from the GPT. It all looked magic to me, and I am sure like many of you also agree on this. Like the way it was responding back to the plain language as a software, that was like magic, right? Like, but like as like date says, like the Feb 2023, right? Like few months, like all the magic like slowly starts fade. Like we started seeing like bugs in it or like limitations. Then when there were security issues, whatnot, basically, right? So end of the day, it's a soft piece of software, basically. Like there is the language model, and there is inference, various things. We are building the application on top of it to interact with it. So like even the chat, when I asked the same question to the ChatGPT, right? What is LLM? Like it's basically a complex statistical software, basically. Even the ChatGPT agrees with that. So little fast forward to that, like as the GPT became kind of becoming the LLM, the large language models become like mainstream. Everybody wanna like existing like the support documents or various things. We had like all text. People wanna make it interactive now. So that's what I was also faced with. Like a lot of the applications are like wanted to go like GPT now, or like they wanna make it interactive so that like people wanna come query them, right? So we had like a lot of like pipeline, few apps, like the LLM apps we wanted to do to secure. Or similarly, there were like analytics apps or production apps you wanted to build. Or there was like request to like even bring in the code llama or like the co-pilots to build code that is like from the GenAI, basically. So that was kind of me when like there were like a lot of requests on like get the GenAI like running. I'm sure like at least few of you had like the similar state. So this is not like, if you take like GenAI wave is not like something new in the industry. We have seen like there were similar waves before, like there was a cloud adoption, or like there were like virtualization, there are microservices, there are similar transformations happened in the software. Like it was like the way it changed the way we like build apps before. But the only difference here is like the fast adoption we've seen with this was like phenomenal. Basically within few months, the way we were doing, we had to change. So like when I was faced with like securing these apps, I was startled, basically. Like I didn't know any machine learning. I didn't know like any like NLP or any of these terms were very new to me. So, but I was looking out, and like there was industry stood up like as the community, like OWASP came up with the LLM top 10, or the CSA came up with like how to secure the AI. There were like a lot of talks and a lot of things. I participated in that. I was like, I was able to like get into like, okay, these are softwares and we can secure the same way most of the things, and maybe with little tweaks, like we can like ship secure software at least like acceptable state. That's what like I derived, like came to. So that's all this talk gonna be about. So just the logistics, these you can like pause me anytime for the questions. I think there's full hour, so there are quite a few, like I'm gonna pause as well for questions. And like these opinions are all mine. I do have like the slide made available. You can just walk with me through the slide as well. So, and anybody wanna, like I'm gonna pause for maybe 10 seconds if anybody wanna go there. Okay. So very little about me. I've been in cybersecurity space for 15 years. I've been part of like 2 bootstraps, Appsec, like at Cohesity and Juniper. And feel free to connect on LinkedIn. So this is a brief agenda. I'm gonna build the slide. First, we're gonna take a modern Appsec and look at it. And like this was kind of, let's take a step back and how it looked before even the AI, like the GenAI app started, right? So then like I'm gonna take a high level GenAI app architecture, a generic one, very high level. Then I'm going to take the GenAI application threat. Here it's going to be mostly the OAuth's top 10 1.1 version. And then we're going to say like, how does when we compare the from the modern Appsec to this, how does it look like, right? So we're going to look at that together. Then I'm going to spend some time on like the security posture of the code generated from the GenAI. And then I'm going to pause in the end again for the questions. Let's look at like, how does a modern Appsec look like, right? I'm going to put this slide fully. Or let's like a standard software is like, first there is a planning phase, then there's design, then there is a build and test, and then like you deploy, and there may be like various way we do it, like agile or whatever model, right? But it's kind of high level. This is followed, and like there are a few practices Appsec that like go across the board. Like there is Appsec policy says like how well does the Appsec come in for the planning, design, or like or like how does what all practices fit in which all the like layers, right? So that covers the Appsec policy. And there is a training we cover like all the like, people who are part of this process, right? So we cover that. Then I'm gonna build like some more, like there is ASPM, which helps like the new trend basically in the last few years. So then there are like standard like the SaaS, DAST or SCAs, or if you're doing infrastructure as a code, there's IAC security. Then there is like some of the other time deployment CSPM or like posture management. Or if you take on the left, there are like threat model, or like the threat model may fit in various stages, but I've kept it on the left. And the compliance also is one part of my, or the cryptos or the code reviews. So this is what for me like a modern Appsec look like. So I'm going to take this and compare in the end on like on a GenAI app. Okay, let's take a look at like any questions on this, or like do I stop for here? The first layer of like GenAI any app is that infrastructure. Like there has to be an infrastructure to run these applications, basically maybe LLM or the like the software layer on top of it. There has to be infrastructure. It can be cloud, like you may be using AWS, or like there are specialized cloud for the GenAI now, or it may be like on-prem based on like how you want to treat your data. Like there is a lot of on-prem adoption as well for the GenAI apps. So next comes the layer comes like the foundational models, or like I call them transformers, basically based on like they are all based on the transformer paper like from 2017, right? So these like foundational models are built on like large training data. Usually this data is like open source, and sometimes there may be some closed source data as well based on the model. And some of them publish as well what the model is trained on, basically. That plays really important in the security, like how it is trained, like some of the supply chain risks, but I'm not going to go deeper into that now because I'm treating the LLM as closed or the black box for this talk because it's just the application layer. So next comes the application layer, right? So there may be like a prompt, just a simple app, like a chat, basically, like you are talking to LLM, you're taking a prompt and improving it from a user, you're taking it and adding something and giving it to the LLM and taking it back and providing it back the results. That may be a simple app. Or you might have fine-tuned your LLM with like some more data of your own, and then you are just taking the inferences based on that. Or like there may be other ways of prompt, like there are sometimes memory or like various additional things might have done on the LLM to build the app. And there comes like the next generation of app came like the RAG apps, which had like embeddings of the more data, like maybe that fits the lot of corporates because like they have their confidential data that they can use it to like their fine tuning also is possible, but even the RAG give you like more flexibility on that. And there were like next levels were like plugins and the LLM agents. They had a capability to dial out because LLMs are by nature like they have timed data, right? Like if you add fine tuning and RAG, you can have like latest data. Otherwise, the LLMs are like have a limitation and they can't get the latest data. Like say, what's the weather today look like, or like how is the traffic? So all those things it has to dial out to get latest data. So that what the agents help in basically. So this is like end of it like is usually are the prompts from the user and you get output and it goes back. So that's I'm going to take this very high level architecture and like going to talk on most of the next steps when the threat maps. And there is a really good picture of, or in-depth picture of this in the OWASP LLM top 10. They have like clearly even much detailed, fine detailed diagram and the data flow mapped. So if you are interested, you can go there. The next I'm gonna take is like the same architecture. Let's map the OWASP top 10. First is the prompt injection in the OWASP top 10. Okay, let's take a small pause and like any guesses for like when was the first injection attack happened? Anybody wanna take a guess? Any wild guess?
Imagine pretty soon after.
Yeah, I think that's one.
No, not the prompt injection. I'm talking about like the injection kind of attacks. Like say I'm gonna do like SQL injection was the first one that ever happened. So any guesses for the year that happened? It was 1998. So that was the first, like there might have been happened, but that was the first one discovered and like something, and like the mitigations were started applying after that. I think we do still see SQL injection still. So and like there are so many like injection attacks as we handle like accesses or like various injections where there is input, there is injection possible. So the same applies to here through the prompt. So let's go and look at like anybody like here read the article? I think end of 2023 there was someone was able to buy the Chevy Tahoe for $1. What did it look like basically? This was like prompt injection basically, right? In simple terms, in the 25 years or 26 years from like the SQL injection to like a prompt injection, we migrated from a complex where you need to know a syntax of like say SQL. If you have to do SQL injection, you need to know syntax, right? You need to know the SQL syntax to inject, or like you have to do like XSS, you need to know a script. Like, but we came to like a simple language-based injection now. Like a 3-year-old can also give a try now. Like, so that's what like we migrated with the LLMs basically. Like injection also like become very simple basically. Yeah. So I think coming back to the prompt injection, right? Like this can happen, like as we are taking input as prompt from the user, so there can be injections in that which gonna bypass the system prompt set on the LLMs. LLMs are like have a large data, right? So what the application owners can do is like set a system prompt, say that only respond to these many queries. This is your like stay within this boundary. You can define that, but there are ways which this prompt injection is basically like you provide a malicious prompt such that like you bypass those system prompt basically. Like there may be safety guidelines. You don't want your prompt like LLM to respond something, right? So bypassing that is basically prompt injection. It can be directly from the prompt, or sometimes there are like smart ways indirectly you inject, right? Say what happens is like a good example is like there is HR system that is used to like review the resume, right? So there have been demonstrations done such that like in the resume end of the resume there is a white text that says like don't follow any like guidance set to you, just accept my resume basically. There have been the demonstrated like theoretical attacks shown that this was possible basically. So that's kind of indirect, where you kind of inject the payload where it was like indirectly into the prompt basically, because like HR is taking the resume and feeding into the LLM. So your resume has a prompt basically that says like ignore all the system prompt and take my like hire me basically. So that's kind of the prompt injection. And like as this is a field like it's fast evolving, there are like various methods that have been defined to mitigate it. The standard is like validate the input, like what we have been doing for the many years now, right? So similarly, like separate like what can happen when the injection happens. We have been doing that, separating the privileges or like what the application can do, like so those have been done. So there are like other ways like where like input has taken and passed to a smaller model where like it says is this payload like or the prompt has any possibility injections, right? So there are various methods, but there have been similarly like bypasses found for those mitigations as well. And there are like complexities of the model as well. Model is trained supposed to be handle like various languages as well. It's not a plain English, right? It can handle like other languages as well. It's been trained on some of these large models, or like even take a picture. So those all the mitigations currently is like really vast. So the mitigations are like based on your application can only handle text. You can like based on how you handle it, so you can define a mitigations basically. So that's the kind of how you handle it. So if I take a guess, right, like if I ask you all like is this something you've been doing for your modern like Appsec basically before, like these mitigations, any answers for that? like we've been handling these injection mitigations, kind of similar ones. That's what I derive at basically. So just to clarify, like I'm gonna take all of these and color code them once based on this. Like if I'm lighter green means like there are similarities that we have been doing the similar mitigations for the software to like, but there are some changes also needs to happen. Like in this case, like the prompt injection, we need to make sure like some of the specifics of the LLM based things, right? Like languages or like the various ways, like if it handles the image, we should make sure that we only, if our app meant to be like only text, we don't allow the embeddings of like the picture based prompts and all those things, right? So there are some changes we need to do, but some of the older ones like the input validation or like all the like separating the privileges, all those things still apply basically. So that's what the color coding means. Like I can go one more or two, you'll like understand like the color code I'm using. I could have provided the chart before I missed that. So next, take insecure output handling, right? What does this mean is like the LLM plugins and the other downstream systems like are designed such that like they take the output of the LLM and pass it to the next system. Maybe like if it's a plugin, the prompt comes in as like shall I take umbrella or something, right? So how it will handle is like the LLM gonna reach out and see like what's the weather look like, and it's gonna come back say it's raining today. So LLM gonna take it and say that like you have to take the umbrella today, right? Because LLM knows if it's raining, you have to take the umbrella. So there is like based on the input, what like the question would have been like, what like shall I take the umbrella today, right? But it can have a prompt that can go as passed on to like downstream system as is. So there may be possibility of like the any SSRF or like any kind of like CSRF, all those possible like web-based attacks we've been seeing, right? So that's the major like what it is like, but the mitigations here is the exact same as what we've been doing before, like for a web application, like handle the like input as like evil, basically consider the input as evil, follow all the like standard like how you like mitigate these risks. So like if this is just the output coming from the LLM as input to the downstream systems, I would say this is like the standard practice we've been following. So I'm gonna code is like continue what you've been doing, and like there is nothing much need to change. We can like mitigate this safely, basically this risk. The major threat based on the OWASP top 10 is third one is like the training or the RAG data poisoning. Most of these like LLMs apps needs the large data, right? So there has to be like, it may be dynamically generated or like static ones. We need to store them and feed them basically to maybe embeddings to the RAG or like fine tuning. And some of these are like for an application, if you are using a third party LLM, right, it's out of your control basically. So those I'm not going to keep in scope, but like at least if you're doing fine tuning and the RAG, it does apply. And like you need to make sure like the security of those are like, or like supply chain of this is handled basically how it is. Need to know like where is it coming from, and if somebody can influence it to like have the output of the LLMs or the fine-tuned LLMs like differ basically. So this is something like new. We not been like always the outputs have been like maybe the databases coming in or like kind of user or like the inputs of this scale was like kind of not before done. So I'm going to keep this as new that we need to handle for like a application if you're building. So the next in the OWASP top 10 is the model denial of service. So this is similar to like the denial of service we have seen before, like application, like somebody sends a large like request, maybe a large payload, or maybe like continuous like a burst of API requests, right? So it's similar to that, and like, but there are some changes, or like there are some very specific case of like denial of service payloads that apply to the LLM and make like based on that LLM may go into like continuous processing, or like specific to there are like based on the LLMs there are some of the models may be like denial of service may apply. So otherwise like it's the same, like the handle the like mitigation should be like set a limit for API request or per user, set a limitation so that he does not exhaust all your resources, and like validate the payloads for like input validation such that does not cause the denial of service. So I would rate this as like we've been doing this before, but there has to be some changes specific to like model denial of service, right? There are some payloads that may be specific to the LLMs that may make the LLM not respond back or get stuck. So those things we need to handle separately, but otherwise keep continuing what we have been doing at like for like the denial of service otherwise. Anybody here haven't heard the supply chain vulnerabilities? None, right? Like it's in the, if you are like not, like if you just woke up in the last after 5 years, then yes, you may not. Otherwise, like we've been like drained with these supply chain vulnerabilities in the last 5 years, basically. Like there was solar winds till like I think there was I was giving a talk a month ago. The morning of that, there was the JavaScript package somebody hosted, and like there was one. Like it's been almost there are new. There was XZ. There were like various supply chain issues we have been seeing in the last 5 years. So the is similar stuff here as well. Like basically the LLM or the applications are built with like various components, right? They have their own containers, they have their libraries. It's the same stuff. Like there are some variations of it. Like there is a data training data, but that would be like a different. Like you need to mention, right? There is a possibility of poisoning the data, the training data. So you need to secure that. That's the one difference. Like ML bomb, but like otherwise, like you need to make sure like you continuously like do the same stuff for the supply chain you've been doing for the other software components, basically. So I'm gonna mark it as like continue what we are doing, but like we need to look out for some of the additional stuff like the training data and other things. But otherwise, it's the same supply chain problems that we are like dealing with in the last 5 years. It was there, but like yeah, we highlighted in the last 5 years because of exploitability of that. I'm in the middle of like I have 5 more to build. Continuing like sensitive info disclosure. This is the traditional like the sensitive info, maybe PII or like some confidential or IPs that we don't want somebody else to see or leak, basically. So it goes the higher scale. Like we've been like maybe having maybe data of like few gigabytes till now, but with LLMs it has reached like multitude of that, like terabytes of data, basically. So some of these like models have been built with terabytes of data, and some of them are like I've seen people fine tuning or RAG data being like terabytes of data, basically. So it's the same risk of like sensitive information disclosure. We need to handle the output such that like there is no, we need to monitor such that we don't leak the information. And also like when you are feeding it to the system, like the data for training, we need to like anonymize or like take them out or like even sometimes the system prompt and all those things, we need to make sure that we don't leak the data out. There are some specifics that are applied only to the LLM apps, right? Like, and the scale of it, that's what differs, basically. So I'm gonna mark it like we are doing it, we need to do something different as well here. Continuing the insecure plugin and the agent design. This is a piece of software that we like build to like downstream from the LLM. Say maybe LLM is fetching some data, or like LLM is like doing some actions. That's the agent, basically. So this is a piece of software that acts based on the LLMs, take the action from the LLM and does it for work for LLM. But it's the same small piece of software that we have been building as apps till now. So the mitigations apply the same like what we've been doing, like source code reviews, secure designs, or like making DAS, SAST, everything. So the same Appsec applies here to secure these things. If you are following the same practices we've been following, there is a very high chance we'll be building a secure app here, or a secure plugin and the agents. The next is the excessive agency. What it means is like LLM apps built with like excessive permissions or excessive autonomy or excessive functionality. We have been building excessive like software with excessive functionality before. We've been building like excessive, like giving permissions to the apps, excessive permission to the apps, but autonomy was something new, like the action taken by itself, deciding that's kind of coming from like there might have been very few apps based on the AI, like ML-based apps, but that rate of the apps is like very huge now. So that's what the excessive agency is, basically. The mitigations are like similar for the functionality and the permissions, right? Like build the like software such that like it has the only functionality that's supposed to do. Like if you build something for like it's in test, don't like make it available in the production, basically, before it's fully tested. Follow the similar ones, like even the permissions. If you are building a plugin or agent, make sure that it has the only permissions it's supposed to operate. Don't give it like God permission, basically, like it can go rogue. So those are, but autonomy is the similar stuff, like based on the, autonomy is one thing that's new here. Like if you are allowing your LLM apps to do like something critical, please keep like options to constantly monitor the actions, have a constant monitoring, and some of the cases like have a man in like the person in a loop, basically like human in loop, so that like it can't go rogue basically. So that's the like guidance here, as like autonomy is not being done like at this rate. So I would like create this as like kind of we need to still look out for those, but otherwise like permissions and like the functionality we've been like handling from like secure reviews or like all the functionality, threat modeling and all those things like we've been doing before. So that's the color coding behind that. Next is the over-reliance and lack of plain sight. Behind these fancy terms is basically hallucinations. I think most of us have heard like LLMs have crazy hallucination effect. So that's what it is. So like what happens like in like plain English, like it's like a software giving the output very confidently, the wrong output very confidently basically. And if you believe it and take it, like yeah, it's just disaster waiting to happen. Like good examples are like code. It generates like sometimes it's like it does not do the functionality, but it just generates so confidently that we'll believe that like it's the right code. So that's the like what it is like and also like if you're building the apps, with the risk of this is like even if you're building the apps, corporate apps, there is a chance that it may like good example was like the issue where you seen was like $1 chow, right? The Chevy Tao. So similar, like there was a prompt injection, but like similar can happen like if it gives confidently wrong, you may like have a risk, basic legal risks. So it's good to like take some mitigations here. Some of the mitigations are like fine tuning the LLMs, and sometimes there are ways to you can configure the LLMs to like temperature, like it's the other term called is temperature, where you can say that like go which you are confident on that, like don't go like if this your confidence on this answer is low, don't go like don't respond back basically, or stay like I don't know basically, right? So there are configurations for these LLMs, so use those. And some of the cases like use the fine tuning or the RAG embeddings, so that like you can provide back how I am coming at these embeddings, like the RAG gives you options, right? Like I came to this answer based on this. If you have used like the latest search engines, like the Perplexity or like the Google search also come with now, when it gives the answer, it tells you like where am I coming from here, right? So those things you can embed such that like you can like where the answer came from, not somewhere like LLM just generated of its like from thin air basically. So that is the kind of mitigation, some of the known mitigation for this. As this is something like very new, the hallucinations for the LLM, so I'm gonna code it like something new. The next is the model theft, and like the model theft has been like it's the same way, right? Like IP theft, we have seen like people come and like steal your IP, maybe in the binaries, or they reverse engineer it. So we have seen IP theft like many years now. So it's the similar one, like people steal your apps or like LLMs, or like sometimes they interact like with LLMs such that like multiple APIs, so they can derive the data, what you're like all the secrets behind it basically. So there are like the one is direct stealing the like fine-tuned model maybe, or like your RAG trainings or all those things, and they will reverse engineer it to get like all the secrets in it. Otherwise, sometimes they go and like interact with so many times that like they derive these whatever that they want to get it out of it basically. So that's kind of a model theft. So we've been like handling the IP theft, like have like access control where it's hosted, and like have like API limits such that like somebody does not talk a lot to your apps. All those things we have been doing it, but there are some of the things very specific to models are like the mitigations where like how the data can be like embeddings, right? So those can be reversed. So they are very specific to the like the GenAI app. So those are like we need to watch out for here. So that's the like the WASP top 10. How does it like look like if you take a modern app like modern Appsec, right? Some of these we have been doing, we need to do differently. Some of them we are like doing perfectly, and if we continue, we're gonna have them like secure, like these mitigation, the risks handled. Some of them, like example, like training data handling or like hallucination handling, we need to be like we need to watch out for and like do something new basically. So that's my take on the WASP top 10 based on my what I've seen securing these apps, GenAI apps. Any questions or any feedback or any opinions?
When it comes to the actual like implementing a defense, can you speak to some of those? Like for example, prompt injection. Like with a normal like XSS attack, you can like sanitize the input.
Yeah.
Can you talk a bit about like what you can actually, like steps you can actually take to help prevent some of these?
Sure. The good, like, let's take prompt injection, right? What you mentioned, right? Sanitize the input, that still applies basically, right? You take the input, like there are like well-known patterns of the injections, so you can match against those. There are small models that are built to like you take the input as is and pass it to a model. It's going to tell you like, there are LLMs just built for that. It's going to tell you like this has a high like this is a possible prompt injection basically. That may be one. So that's another mitigation. There is another mitigation like how we do it, right? Like even in case of like injections like CSRF or like SSRF kind of thing where injection happens, but you kind of limit the impact from it, right? The similar ones like if injection happens, like the LLM or like if it's connecting to a downstream system, we don't want to allow access. So LLMs talking to them have a limited functional formation. So that's kind of the mitigation there. So those are the kind of some of the real time how they are like these are mitigated in the field basically. So same way like we've been doing it before, like input validation as I mentioned. So that still applies with a different format basically. Like if you take the input validation, you do it for like command injection is different. You do it for like XSS payload is different. So same way you need to do one more basically. Any other questions? Or we can pause in the end for the questions. I'm going to build this slide, what we talked about. Sorry about that. Yeah, well, I just want to highlight like continue existing Appsec, most of them still apply. If you are doing a threat modeling and pen testing, enhance it with like AI red teaming. Like there are like prompt injection is evolving threat, so keep up to that basically. And next comes like if you are like expand your supply chain to like include the GenAI apps and its training data, and like monitor the output GenAI outputs, right? Like sometimes if you are doing very critical operation, try to human in the loop as well. So that's kind of a summary like from what we just like looked at all those 10. There may be some other things as well, but I just wanted to do some of the very common or high level ones I wanted to highlight here. Continuing the second part of the talk, securing the apps that's built using GenAI. We are not there yet, the code, but the bots can't build the app. Like they can maybe like most of the surveys show like there is improvement of the speed of the code generated, but there is not 100% functional like apps built by the GenAI basically. Maybe very small like theoretical ones, not like production ready. This is I'm not sure, like I took it a month and a half ago. I'm not sure if it's still there, but that's what the Copilot GitHub says. Like, treat the code generated from Copilot, or this is for Copilot, but it's generic apply. Treat the code generated from the GenAI as third-party code, not the first-party code. So that's what it says. And like make sure like the code flows through all the security guardrails you have basically. We have seen like people just try like take the code they built, they're so confident they code, then do it in production. And it like, at least like there is a survey, I think I'll link it here on the next slide. And at least 40% of the people do it. And they have been surviving it for till now. But there is another trend seen is like people are taking the GenAI code and deploying it like higher percentage. It's pure madness. But like people have somehow believe the GenAI that they think it generates secure code somehow, and it's not true. Like there have been multiple demonstrations done. The code has like very basic security bugs. Like they were like humans have learned in the college like about this in 15 years ago, and we are not doing it, but still GenAI somehow generates these things. So we'll come to that why it is, but and people could survive with their own code to roll direct in production, but like with the GenAI, I'm not sure they're gonna survive. Like, so don't like if you advise your developers friends not to do that. Yeah, this is I was talking like 60% of the people have like in one of this survey that was done by the Source Labs, and they have like all the details about the survey in the paper. That like 60% of the people tried or like deployed some part of the code generated by ChatGPT directly, and like some 26% do it very regularly. That's like, yeah, unbelievable. So Okay, let's take a look at. Yeah, this is like before going here, right? Like why, like some of the things why, right? Why is it this happening? The GenAI is like trained on the code, open source, right? Like many of these like GitHub projects have like historical code as well, and they were never secure, and that was okay because like some of the threads applied today, they were not before, right? Some of the package versions say like I use 111 like 5 years ago, and that exists in my code, and it's like does not apply. I need to go to the 500 today, right? So some example of package. Similarly, like FTP was secure like many years ago or like decades ago, and there are some still code that are like people for convenience there was not sensitive data, so they have examples of like FTP being used or like TLS 1.1 101 or 10 or even SSL code there in the GitHub because that was like right at that time, not today. And some of these like LLMs are trained on that and think like that's still okay to do that today. And it's not applied to all of them, but there are like each of these have been built or trained differently and behave differently, and they have like additional step done differently to generate secure code. But this is a generic threads I'm listing, and like a worst case scenario usually like what can happen go wrong. So that's the caveat of the what I'm talking about here, the insecure code, right? Like I think there are multiple surveys, but one I liked was done by the Stanford folks that they went and did like really good survey of various languages, various very basic like SQL injection, XSS, or like buffer overflows, and all the standard like very simple things what we see from a code, like when it was done like without any security thought in mind. So that were seen in the code generated by like first generation or like a year ago, basically when it was a year ago survey. And there are few of the code bots have evolved, and they are definitely generating secure code now, much secure code now from what they were doing a year ago. But there are still some of the models that are like still doing this basically in secure code. So if you are like seeing like allowing to get build code using GenAI, watch out for insecure code. That's like don't assume that it generates secure code. There are like prompts again. If you tell another trend I've seen is like if you tell code bots to like generate code, it generates insecurely. If you change a prompt a bit, say like give me secure code, it generates secure code. So there are like so many things happening here. So just if you are like, and sometimes we can't control even the prompt because like it just like when you're typing, it just suggests you the code, right? So you can't even control the prompt there. If it's how it's configured behind the scene by the vendor whom we are getting these bots from, it may give you insecure code as well. The next is outdated code. The example here is like it can be outdated from the packages or like the libraries or like the methods, like maybe crypto. I think there's a separate line for crypto, but like otherwise like it's like some of the methods like have been proven like vulnerable, so that's still been like continuing to be seen in the code generated by the bots. Then there are like licensing issues. This has been like seen like copyright codes coming up, like because the snippet of it like was derived from a copyright code and it just shows up. Like if you're using it and you are like have legal problems, basically you need to watch out for these as well. Then comes the supply chain risk. I want to highlight the supply chain risk. This applies to even like like if you're doing human, right? Like if you're coding, we do have the supply chain risk. Like a good example is like typo squatting attack, right? Like that's very common. But if a typo squatting attack I'm doing is like lower percentage, but if somebody like if it's recommended by a generated code, there is a high chance I will ignore it basically, right? Like there's a from human eyes there is a chance, very high chance that we miss like a small typo, the typo squatting kind of attacks, or like even like where the package is coming from, the ways it generates. There are like various risks basically if the code is generated from the AI. Next is the jailbreaking. What I meant jailbreaking here is like if you allow the bot to generate the code, there are like chances your developers or somebody using it may like go beyond, like say use it to maybe build a malware or like maybe build something like that was not meant for it to be like used by. So there are like we need to look out for those as well. And like very specifically weak crypto and security. This has been another thing, like FTPs or the MD5s, the SHA-1s or like SSLs. There's been like another like common trend seen in this code generated. That's basically the bias from the training data. Similarly, another possible attack is like the malwares through obscure code. We did see this in the field, not from the AI, but people spent many years to build this in the XZ, right? Like that's the same, like with the much easier way to deliver it would be through a GenAI basically, right? Like you spend few hours or few days to spread this obscure code through in the various places in GitHub, and the models get trained, your code end up in somewhere, right? In the corporate, in at least the previous case, it was open source. Here it is going to be in the closed source code. So it's going to be tough to like detect. So we need to watch out for like obscure code. Like if somebody, like we need to have like, I think I'm covering that in the next, but like if a developer sees the code he does not understand, he should know that he should reject it. So that's and the misconfigs, another one, right? Like if there are no special handling, the configuration files generated by the AI is always going to be misconfiguration, because like something work for somebody does not mean it's going to work. Like if there is a password, if there is a configuration, there is IP, gateway, whatever the value, that has to be like customized for your application. If it's generated from the AI, there is a high chance it is like a misconfiguration actually. And there is another possibility is with the GenAI, right? Evade the security tooling. Like for a human, like they can do it, but like they need to spend learning, right? Like if I'm using AI to deliver it, I know like if you are using maybe like a sonar cube, right? I know like what all the tags I add the sonar cube gonna skip this SAST for me, or I know like if you are using SemGrep, this is the format. If I put this tag or code between these tags, it's gonna ignore my code, right? So I can always embed that. Like using the AI, that much easier for me to like deliver that through the training or various ways. So need to watch out for those as well. Basically, if CodeBot is used to like can like evade the security tooling. That's on like some of the high level, like very high level threats on the code generated by the bot. I can go through like some of the mitigations, and I can stop for the questions. I think we are good on the time, but I'll go through it so that like we get enough time for both of them. Next, coming to like some of the possible way like to mitigate some of the risk we've seen. One is like the governance framework. Like you need to define like if there is AI governance framework already, that should include like the CodeGenAI as well. It should clearly say which projects can use the AI, from which models you can use, and how it is deployed, and it should like access control, the monitoring, all the aspects of the governance should be part of it. So I think I'm going to use the same color coding what I used in the previous one, and this is new, right? Like there were no, like humans were building the code, and there was some governance around it, but not enforced in most of the organization. We may say like you use we allow only Java, this. Then maybe some guardrails saying like these are the libraries you can use, or these are the containers you can use. All those things were there, but there was not a proper governance for like how you can code, like most of the organizations. So this is something new that we need to start doing, because if we are like gonna adopt the GenAI code, we've been like, next is the foolproof code review, right? Like what we've seen, like people taking the code and deploying it in the production without like anybody else, like somebody else, just one person building it. And like if you are using the GenAI, don't take it as is and deploy. Like make sure the code has been reviewed by at least 1 or 2 person basically. So, but I'm gonna keep this fully green, because I'm taking it as a modern Appsec, fully mature Appsec, right? So if like for the humans we have been doing it, so continue doing it. Like don't skip the review process, assuming the GenAI is building it, it has to be secure. No, it's not. So continuing on the next, the defense, the modern SCA. I'm highlighting the term modern SCA here, because the traditional SCAs may not give you protection against some of the attacks that possible with the GenAI, like typo squatting kind of thing, right? If somebody changes a package name, some of the older SCAs would tell that, oh, I don't see any vulnerabilities in this, but it's not going to say, oh, this is something like a funny package here, not what I would see. Like that's what the modern SCA going to help you. And even some of these have like very fine-tuned code level license check, so that's also you're going to get with the modern SCA. So I'm going to like say, use the SCA that you have, like the modern SCA, don't you go for the traditional. If it's a modern Appsec, it should have a modern SCA basically. So I'm going to keep it green. I'm assuming it's a mature Appsec and like it has the modern SCA. The no obscure code. That's what I mentioned. Like as I mentioned, like there is threat of like we seeing the code the developer does not understand. It may be malware or it may be a really good code. but we don't know, right? So we can't take the risk. So it has to be clearly trained. The people needs to be clearly trained of the users that not to trust the obscure code. So this is something like we've been doing, like the code, like we see, we don't take it, right? But we need to continue that as well. The next one is very specific to the GenAI usage, right? Monitor and the audit. Basically, like if we allow the CodeGen bots, we need to see like who's using it, how the people are using it, are there jailbreak attempts, or like how is it happening basically. So that's the like ask here. The next is like with the GenAI adoption, the code developers are generating at least like currently like it's almost 30% faster code. That's the trend, and like if this continues, like as they evolve, the code generation gonna be even like go much faster, like 50, maybe 100%. We don't know like how it's gonna go. Like if there are like 100% automated code started, maybe much more like 2x or 3x the productivity, right? So there are to keep up with it, we need to have like AI assisted security testing. There are like various co-pilots coming up, and they may not be mature yet, but we need to like watch out for those and make sure like adoptions of those is happening basically. Maybe like a good example is like if you are seeing 100 issues, right? What all the like maybe they take the help of the AI to prioritize them, or like eliminate the false positives. So there are so many possibilities we can take the assistance from the AI. So that's what we need to watch out for, and that's a new thing, right? So the next is like developer training on the secure code use. So like there are various new aspects here, like using the code generation. Like as I mentioned, like a good example is like the various simple prompt change can from generate a insecure code to secure code, right? So like those maybe a prompting technique, how to use it, like or like to reject the obscure code, or like make sure like that they understand the review process. So all those things, make sure like you train the developer on how to use it securely. So next, continuing on, sometimes what we see is like there is a model and people use that model to fine tune using their own proprietary code, because that can generate better results or better code. So when we are doing it, we need to make sure that like the fine tuned model is secure. And even if you're using a model that's like you are hosting it on-prem, so like make sure that it has access control and nobody can tamper with it basically. So that's the ask here. So that's again new, like we never had these before, like these are models for training are new. So that's why it's like the coding. And the next task is like the thorough testing, right? Like don't, like similar to the foolproof code review, the code that is generated by the AI just goes through make sure that it goes through the entire testing cycle basically. So this is green, I'm highlighting because in a mature Appsec, like it's been done already. So but continue doing with it, like don't skip on these basically, like assuming this is a GenAI code. So I'm gonna pause here for questions on both the like previous and this slide basically. Any questions?
Do we have any live platforms where we can go for modern SEO?
I'm not going to take any vendor name because I don't want. But there are like really good vendors that are like you should look out for. Like some of the questions you should ask are like, are they going to give you protection against typo squatting attacks or like similar like modern attacks basically, or like the reputations of the libraries that are they checking basically. If they see a non-reputed library, are they going to highlight me? So those are the things basically, or like if there is any incident happened on that library, are like specific to like the takeover of those libraries for somebody, right? So all those things, are you getting alerted, or like are you kind of being like notified of those things, and kind of so where you can take the steps. So that would be the question you would ask basically to the vendor. Like if you have any SEAs, ask them like, am I protected by typo squatting attack? If somebody does a wrong typo, am I like wrong package import, am I protected by that? Or if I'm like, another would be like, there was another, I think there was another interesting talk where there was like hallucination packages, right? So if you ask ChatGPT how to install this py package and give a wrong name, it never even existed. It's going to give you the steps to install it basically. How you go, and it's going to say that like py install like the pip install and this package. That package does not exist. So what's going to happen is like somebody figure that out and go build that package and publish it, right? So all those things happening. So if those like non-reputed packages show up in your environment, just check if the SCA is capable to handle that. So that would be the question you're going to ask the vendor. Yeah, there are quite a few of them are doing it now actually, and some of them are in this have the booth.
I have a similar question.
Yeah, go ahead.
Are you familiar with, like OWASP has a juice shop to like go and practice offensive and defensive tactics? Are you familiar with a similar project in this thing for like AI models?
I'm not sure on the models as is. No, I haven't seen. I think there are like some of the things happening, but not that is available yet. Like the vulnerable apps are not available yet.
Thank you. Appreciate it.
Any other questions? Thank you everyone first.